Hello, X2. Hello, hello. Just writing a message and then I'm gonna start doing stuff. Okay, sorry, still answering some messages. Do. Okay. Do. So what are we doing? Well, we're doing the same thing that we do every day. We just work on projects. What else is there to do? I should probably announce the stream. Do. Hello, Drex. Hey, happy to catch a bit of the stream. Have you seen ZML? I have, yes. As in, I know that it exists. I know the company. I met some of the people that work at ZML. I have not used the product myself because I don't do much with AI right now. But yeah. In any case, quick impression thoughts. They use Zig. They sponsor the Zig Software Foundation. I know it's a French startup. I know that their goal is to basically make it so that you can take machine learning architectures and implement them in a more efficient manner than, say, PyTorch, for example. And so I guess the idea is, and by the way, so take my words with a grain of salt. That's like the impression of an outsider. So I might be missing part of the story, but I guess the impression that I got is that you have a network implemented in as I said, PyTorch or something like that, and then you want to kind of make a, and you did that as part of exploratory work, but then you want to make it a proper product, more efficient. You want to deploy it on different hardware, like on heterogeneous hardware, or target, I don't know, embedded, that kind of stuff. So you implement it in ZML, and they give you cross compilation, and then I might be wrong, but I believe that ZML is not dynamic in the same way that PyTorch is, and so that's also another way in which you get performance. I think I saw a stream where somebody from ZML was taking from Hugging Face a network and just straight up re-implementing it in ZML. So yeah. Has any of it informed some of the library stuff yet? As far as I know, no. There might have been some PR, maybe sent or some issue opened by ZML people where they asked for, maybe they found a bug or something like that. But no, so far I don't think so. That said, I think that in our case, what would happen is what we would want, which we currently don't have, which might have a relationship with ZML, although I'm not exactly clear on precisely where, is that we're working on a SpearV backend. So the idea is that once the SpearV backend is ready, you will be able to write GPU shaders in Zig. So you won't have to write a GPU shader in GLSL or Metal or HSL. HLS? I think it's HSL. In any case, there's a few different shader languages. The idea is that you won't have to use those. You will be able to use Zig, because the Zig source code will be compiled to SpearV, which can run on all the GPUs. I think that has a relationship with ZML in some way, but it might be that we're definitely entering the space of things that I don't know precisely. So that's a useful thing to have for sure. As for ZML and machine learning in general, I believe that maybe they might be more interested in a MLIR backend. So taking Zig code and turning that into MLIR, but that's kind of what ZML is already. So, but the difference is that ZML does that userland, obviously, while a MLIR backend maybe could do things differently. Sorry, this is the part where I'm not exactly clear on what the landscape looks like. So in any case, yeah, we know they exist, and the project is cool, but I don't have first-hand experience. No problem. Okay, let me finish announcing the stream because I think I haven't done it on the Zig cord. Yeah, morning Ziggin. Okay, what are we working on today? We're working on the deserializer for our JSON replacement language. And I should say this. Publish new Ziggy. So there's a, if you go to ziggylang.io, you will see that there is some information about it. It's slightly outdated because I made some big changes to the language. I mean, the overall story is the same, but I made some changes a little bit in the syntax here and there. So it's not fully, what you read on the website is not fully up to date. But we're working on regress a bunch of functionality. So we're working on getting that functionality back into working shape, and then we're gonna push, and so that people can enjoy Ziggy and its new direction, which I think is significantly more polished than what we had before. But there's still work to do. So deserialization options. Deserialization options plus a handful. Also, by the way, serializer, you know what that showed me? The serialized options should just be called options. There we go. Oh, we're already doing splat byte all. Delightful. Stringify array. Stringify struct inner. Okay, so this part is good. So serializing is good. Serialization is good. Deserialization is less good. Well, we have to implement it. So options. So right now I'm doing the hybrid options plus diagnostics thing. So I don't know. It's an experiment. We'll see. We'll see how this goes. Okay. So I think yesterday I designed how this stuff should look like. So this interface I like well enough. So I would say we're good. Deserialization calls deserialize inner. Deserialize inner just grabs a tokenizer that we instantiate here. This all looks good to me. Okay. To deserialize inner. Okay, so we grab a token. So first token, we're missing the first token argument. I think we should even be after token. So t.next. Oh, he wants source. And he wants skip comments. True. We definitely want to skip comments. So first token, it's we look at what type we need to deserialize. If it's a Boolean, we want true and false. Otherwise, error location is first token location. We return unexpected. Perfect. Hey, Ayushman. Well, it wasn't a walk. I don't know, man. I'm sorry. There we go. So this part is pretty much done. I'm happy. Let's do numbers, I guess. So we already have some implementation of this stuff. So the nice thing is that we can copy the old implementation in what we used to call parser, which is kind of sucky. Stop streaming in working hours. What do you mean? Isn't it better to watch streams while you're working? I have parse bool and parse int. Why do I have dedicated functions for like what? Why is it like this? Like parse bool is oh because of this. I okay. It's fine. I mean, it's roughly the same logic. I don't see why I wouldn't leave here. So parse int. Well, first of all, we switch first token. And if it's a int or a float, then we do parse float. Okay, now we need to be careful about this stuff a little bit. So it's parse float. The type is going to be t, which we know is a float. What we parse is going to be first token dot lock dot source base 10 on an error. That is an interesting problem. So we're parsing a number. In theory, the fact that we have recognized this token as a float or an int means that it should be valid. So we should not be expecting stuff that makes absolutely no sense as a float. But there might be an overflow. And so that is a possibility. So if it's an overflow, I guess we need to return overflow. I forgot that that could have been a possibility. So yeah, we need a new error. So we return. Actually, wait, what the fuck am I saying? There are no overflows in parsing floats. That because that was parse int before. Yeah, parse float can only, so this should be catch unreachable. And you know what? I'm gonna put curlies around this thing so that we can put a comment and say, the token was already validated and parsing floats cannot overflow. So that's my reasoning. Okay, now we need to do the same for int, but it's going to be different. Because we do parse int. And now here's also parse float. Does it want a base? It does not want a base. There are no bases in float. Okay. Parse float, parse int. Now there are bases. But base 10, that's for sure. If we find a float token, that is still a problem because this is int. Also, we're missing the else unreachable. So this. Okay. So we want to parse the int number, but then it can overflow. So we want to capture the error and assert that error is error.overflow. Let's take a look at what errors we can get from this guy. Overflow and invalid character. Perfect. So we assert that it's overflow. We assert that it's overflow, and then we need to return it. Yep. You know what? I think we should like switch on reachable at this point. I think it's just nicer. Error dot overflow. Okay. Kind of annoying that it is so indented. There we go. I think this is better. Okay. Oh, I can't watch this below from the network. Oh, that's unfortunate. Sorry. Wait. How? Wait a second. Then how are you answering me? Hey, Karitam. Yes. Okay, so we're handling integers. We're complaining when stuff is unexpected. Com time float, com time int. I think we want to do the same. Com time int, com time int. We want to do this. Wait. Actually, no. Com time int is impossible. Also, com time float is impossible. I think. It's not impossible, but fuck it. Okay. Okay, this type is an enum literal. Fuck. Well, we cannot create enum literals, I think, from strings, can we? You cannot serialize untyped enum literals, I think. Now the delightful part starts. We have pointers, we have structs, and we have unions. No, this is vectors. There's any frame. So frame and any frame are gone. Opaque function. We probably should do like a full list of things that we can't, that we cannot deserialize. I probably should put them at top. Let's see, cannot deserialize. I think it should be like this. Oh no, but we cannot do plus plus t. Wait, can you do commas with compile error? I don't think you can. Cannot deserialize. Okay, let's leave it at that then. Okay, what do we have? No return. Undefined. Error union. Error set. FN. Opaque. Frame. Any frame. Can we do vectors? I think we should be able to do vectors. And enum literal. Okay. So these are the things that we should not support. Is it too early to use the new IO pattern for file access? No, it's not. We can do it. Yeah. So booleans are good. Count time numbers are good. Okay, what's there left? Pointer, array. Let's do array. So array. How does doing an array look like? We make one. Hello, nullDref. Child type. I don't know what do they call this stuff. Len child. Oh, and there might be also Sentinel. Jesus. You know what? I think it's easier to do it like this. Array is t equals undefined. And then the only thing that we have to worry about before returning it is that what we put in there is the same length. I was sitting once with it myself trying to get the reader writer to work. Let me try to think what I can suggest to you. Well, tell me a little bit more about your use case. What are you doing? Are you like opening a file and reading it entirely in memory immediately? Are you opening a file and then you want a reader to it and then you read to it a bit at a time, or you write to it a bit at a time? What's your general use case? And then I'll point you at the right APIs. Hey, nullDref, more Zine async I'm seeing. Yeah, more specifically, right now I'm working on the Ziggy data language, which is part of Zine, and ultimately the work that I'm doing now will also flow into Zine. But I'm not working on Zine proper right now. Um, do, 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 do. So this is going to be interesting, I think, because now let me think about it for a second. We want to see a open square bracket token, and then we want to parse a value. So we want to see this. You know what? Maybe some of the helper functions that I had in here might not be bad. I think we do want must. Or we switch on it. Let me think about it for a second. So if first token dot tag is different. Oh, by the way, was I switching on first token dot tag? I was not. So if first token tag is different than left square bracket, we should complain. Then for every element in the array, we want to try. No, we want elem to be try deserialize inner GPA source options tokenizer, and the first token needs to be t.next. So we recurse into the serialized inner, and we expect it to succeed. Oh, we're missing the type. The type needs to be array.child. So we try to deserialize child type many times, and it needs to succeed every single time. So if this works, then it means that we have filled the array precisely as much as we want. So this is okay. And then oh, and then we need to make sure who does next then. Is deserialize inner that does next? It needs to. So we need to assume that it will do next. So we'll be yeah, actually, wait a second. How's that gonna work? I feel like this architecture might have trouble. Oh man, I'm so scared. But okay, it shouldn't be the end of the world. Let's assume that we do next here. So if t.next const maybe right square bracket right square bracket, then we complain. Otherwise, we will have successfully parsed an array. With one caveat. There are commas in here. There are commas, so we need to consume a comma. I don't know, let's just call it talk. So if it's a comma, we continue. If it's a right square bracket, if it's a right square bracket, it depends. Are we at the end or not? So we need an index. Okay, let's double check this. So we're parsing all the elements. After every element, there's a comma. There has to be a comma. If we find a comma, actually, we can do it like this. If there is a comma, then we continue. If there is a right square bracket, and we are at the end, we can, well, I guess we can just break directly instead of continuing and then breaking. But then, if that is not the case, then we should complain. Because there is a syntax error of some kind. I think that's how array deserialization should look like. Let's see, for example, from io.file, there is no writer handle that you can get in fs file. So the write position and write streaming methods have not been implemented yet. From my other file, there is no writer handle. Okay, let me check this out. From io.file, you can call you can call reader streaming, or you can call this is the implementation of the reader. Holy shit. Where's the writer? Yeah, you're right. There is no writer. There's functions for doing writing, but there is no writer interface. Yeah, well, there is no writer. So you're right. IO file is incomplete. IO file is incomplete in this sense, for sure. Let's look at the fs file. Fs file has a writer also. Which gives you a writer, but this writer is does it have an interface to a writer interface? I think it does. Or you can do init streaming. Move to reader, drain, send file. Wait. I think this guy does have, oh, there we go, interface. So yeah, no, I think you're right. I think you still want to use an fs file, probably, if you need a writer interface. Yeah. Yeah, sorry, this stuff is still work in progress, right? Some of it has been ported, but not all of it. So I haven't used writer. Oh, sorry, I haven't had to grab a writer interface from an IO file recently. So I haven't, I don't know precisely exactly what was there or not. Because right now I'm only, all the cases where I'm doing files right now has been either create file and then write everything all at once with a single write all, or do directory dot read file alloc options. So yeah. You hit with threading errors. There's a handle for IOTA writer. Wait, is there? Because I didn't see it. I did not see that. Where is this stuff? Because I see a reader implementation. So I see getters for reader, but I don't see how you make a writer implementation. Sorry, a writer interface from this guy. I have 016 dev 1236 also. And it just has a handle. So I don't know. As far as I can see here, there's just no way of getting a writer. In any case, it will be fixed. Just be patient. Stuff will be ported over, and eventually SCDFS file will be deleted, or something like that. Okay, so returns IO.writer, but it doesn't really work like you would hope because of the compatibility thing. No, it should. I think it should. I'm fairly positive that it should work. Okay, I don't know. Maybe there is a bug. Maybe you are experiencing the bug, but it should work. I guess. Let me put it this other way. If you're using this, which IO implementation are you using? That, I guess, is the next question. And I saw that the IO O-ring IO implementation was bitrot a little bit. So it's missing some, it's trying to set some callbacks that have been renamed in the meantime. So IO O-ring is slightly, you know what? I think, okay, I don't know what exactly is the error that you experienced, but I think there's like errors everywhere. So, so no matter what, you must have experienced a bug. So here's the situation. IO O-ring is no. It does not. It does not. It should not. I'm fairly certain. You know what? Maybe I'm wrong. But no, I'm fairly certain that this is correct. This is fine. It should play nice with the new IO. And if it doesn't, it's the result of bugs. So here's what I know that I can tell you. But by the way, you haven't answered my question though, because to make this stuff, you need to pass an IO, do you not? Oh no, you're right. Because wait, you can make this. Wait. You're right, because you can do an FS file. You can make an FS file. No, but it still wants IO, right? Wait a second. When you create a file, it still wants an IO instance, does it not? Uh-oh. These guys do not need that. No, you're right. There is something sus. Wait a second. This is not... Oh man, it's a bit confusing, huh? The whole situation. Yeah, there are two files. Yeah, I know. But I thought that FS file was also ported over to the new stuff because it does have an IO interface. I guess this IO interface is just not interacting to any IO implementation at all. Yeah. Okay. So for some reason, I was sure that you would need to pass an IO implementation somewhere, but even by just looking at it, we can see that that we don't keep track of any IO. Like we would have to see here an IO implementation if this guy kept track of that stuff. The function to return an IO writer in a fast file, or there's this guy. Yeah, there used to be a adapt to new API thing, but no, this doesn't solve it, right? Because you have a file, now you have an IO file, but then the IO file is missing the ability to make writers. So I think it's just not. It's just a piece of missing functionality. There's a reader, but there isn't a writer. So, yeah. Yeah, sorry. I don't know. Such is life. Here's what I can share. That is useful information that is not in the code. Andrew is traveling right now. He's the one pushing forward this stuff. He's traveling. He will be back around the end of November. So you should expect this stuff to unblock and become better in December. So you can do some IO stuff, but unfortunately it's still a little bit wonky. So have a little bit of patience. Santa Andrew is coming. Something like that. Okay. So we are parsing arrays correctly. Now we need to do, I think we should do enums next. Yeah, actually we should do enums even before array maybe. Or whatever. I believe that this is a case. Yeah, there's enum. So parsing an enum works like this. We switch the token and we say if this token is a I think we just call it enum. Do we not? Oh, first token dot tag. God damn it, dude. Okay, what do we call this thing? Oh, we just call it identifier. Right? Because all identifiers have a dot in front of them. So if it's an identifier, then we return std meta dot string to enum. Type of the enum is going to be t. The string is going to be first token dot lock dot slice source. Else, it's not okay. Okay, so enums are easy. Slightly less easy. First token. Slightly less easy unions. Slightly easy, slightly harder union. So here's how it works. If we see an identifier, then this must be a This must be a... Does this work with unions? No, it only works with enums. If enum is less than 100. Okay, so this straight up expects enums. So if it's a union, we need to find the enum thing, which I think might be here. Yeah, tag type. Expected curly block from const. Oh, right. I think we do this outside the switch. Oh, whoops. Here we go. This should work because I think this should almost. If we hit an identifier, we need to check that this case has a type of a payload of type void. What do we have in union info? Oh, we have fields. Name type alignment. Nice. So for info.fields, if f and so yeah, this doesn't work like this. This has to be inside. So if we find a tag with the same name, f.name, if f.type is different than void, then we should return error unexpected. Otherwise, we want to instantiate this stuff, but a bit more complicated. So if it's void, it's different than void, we complain. Otherwise, if it is void, we want to do return at union init. Union is t. Active field name is f.name. The init expression is void. There we go. Yeah. So this is how, then why are we not using E at all? Oh, we're not using E at all, apparently. Okay, so we can do this. Okay, so this is this skip dot. So with this we have the tag. In a union case, we want to do this. So union case, we want to still do the same check. Okay, so we already do that. Grab the tag, look at info fields again, find the same name. Now, if the type is different than void, then we complain that is not what we do in this case. So in this case, we actually want to say that if it is void, it's a problem. If it is void, it's a problem. If it is not void, yeah, we want to return union init, and the expression here is going to be try deserialize f.type source options. Oh, deserialize inner. T next. Okay. And we cannot return this. All right. This is going to be value. Then we need to do some other stuff, and then we can return value. Okay, we need the right parentheses, and then we will have parsed the union correctly. Let's see. Learning Zig still, is it sane to have a struct allocate itself in a function if I need to pass a pointer to some external function and keep it alive? Zig is testing my understanding of OOP since I'm interfacing with existing audible OOP. Let's see. Is it sane to have a struct allocate itself in a function? Yeah, so here's how this usually works. Normally you have a type, const foo, and let's say that it has some state. I'm just making it kind of simple on the fly. Normally you have this function init, which takes in maybe the value of bar, and then returns a foo. And so in here you do return, and here, and that's your initializing function. Now, if you have this, you're already all set in terms of capabilities of things that you can do, because a consumer can do this. A consumer can do const my foo equals gpa.create foo, and then you can do my foo dot star, because that my foo is going to be of type pointer to foo, because it's a heap allocated foo, and you can do my foo dot star equals dot init. I think you can do dot init. I might be wrong. Maybe you have to do foo.init, but in any case, you can basically you heap allocate the memory for foo, and then you just initialize that memory after the fact. So this works. This is like complete as is. That said, if it's something like, if you have to do this a lot, and you know that this foo will have to exist in an ecosystem where you always have, like, very often you have to heap allocate these guys, then you can also give it a create. So the way it works is usually it's init, the init, create, destroy. These are like the two pairings, but it's a convention. Like, you can call them whatever you want. That said, unless you have better names, go with init, the init, create, destroy. So you do create, and create takes in a bar, bool, and also has to take a GPA. And so this guy returns a pointer to foo. And so in here, you do this. But you're doing it for convenience more than anything else. You're really doing it for convenience more than anything else. But the thing is, if you have only this, and you don't have init, well, let's imagine that instead of init, you do the assignment here. If you don't have init, then you're kind of removing some flexibility from the user, because the user now is not going to be, the user will always have to heap allocate this guy, which is annoying. Or rather, they don't have to, because technically they could create an allocator that works off of stack memory, for example, but it's jank at that point. So this init is definitely more powerful than create. But create can be added for convenience, for sure. And if it's a horrible foot gun to stack allocate these guys, and they always need to be heap allocated, then okay, maybe you take this out to prevent people to make it less likely that people stack allocate these guys by mistake. There's also this option. Yeah, another option is to oh shit, I should not have done this. Whoops. Yeah, another option is is to have init accept a pointer to foo. And so in this case, you would use it like this. You could use it from stack memory, so it would be var foo equals undefined, and then you do foo.init. Or alternatively, you basically do this, but then instead of assigning, you just call it on the thing. So these are like various styles in which you can do this. Let's see. So just make the consumer allocate instead. Yeah, you can do that. I really wanna stuff the WinAPI call inside of create, since having the user touch WinAPI is illegal. Yeah, exactly. Yeah, I mean, you can decide how to tackle that. So I would say these are the general patterns that are used. Now you know about them, and now it's up to you to evaluate which ones you like more, and where to take your design. No problem. So union case, I think we have dealt with union case correctly. So enum is done, union is done. Maybe you should do optional. If anyone is traveling, can we expect talks from him? I don't think so. He's attending a Zig day, but you know, the Zig days are not really about talks. So there's optional, which has child. Okay, let's do optional. So optional. Yeah, the Osaka one. You know what? Also, I think we should rename these things always to info at this point. There we go. Info. Okay, so we switch on what we get. So if we get null, return null. Else, return DC realize inner. Type is going to be info.child. GPA, source, same options, same tokenizer, and same first token. We don't consume it. Okay, this is optional. It's actually very trivial. Holy shit. Pointer. Okay, the complicated ones that remain are pointer and struct. You know what? Optional is so small that I'm going to put it up here with the simpler ones. I think it should be like this. You know what? Optional. I'm going to leave union in enum next to one another, but I'm going to move array down after union. Okay. Pointer in theory also should be simple, but it's not because we need to special case strings. Fuck. So pointer. So what is our first worry? First of all, before we can switch on the token, we need to worry about what the heck is going on with you know what? Maybe I should leave pointer for last. Let's do struct first. Okay, let's do struct. So we have container layout. Okay. We have baking integer. We have fields. We have decals. We have is a tuple. We could say, well, if this is a packed struct, then we expect to find a number. No, but we don't want to encode that stuff as a number. We want to encode it as all the thingies. So that doesn't matter. What matters is we need to... Oh, we also have to worry about like top level structs. Whew. We need something that tells us whether we are at the top level or not. So it's something that is true on the first call, but then it needs to be false every time afterwards. Okay, hopefully I filled out all the places. Okay. I guess the first question is, are we at the top? So if top level, then first token can either be a curly or a identifier. If it is a curly, we skip it. If top level switch, actually we can do it like this. If top level, if not top level, or first token dot tag is different than dot RB, then it's first token, else t dot next. So if start talk dot tag is different than dot identifier, it's unexpected. Okay, so we are correctly at the beginning of a strat, so we can do var value str for struct. Call the result. It's of type T and it's undefined. Now this is where it gets complicated because we need to keep parsing, but at the same time, we need to keep parsing, but at the same time, we need to keep track of which fields we've seen, duplicate fields, like all that kind of stuff. Let's see what the old implementation had for this. I bet you it had nothing good. I mean, it had the logic, but I suspect it didn't have particularly good stuff. Struct if identifier need closing RB. Right. That is a good point. We have lost this information at this point. Although no, we don't have to do that. We can do if start talk dot tag is different than first token dot tag, which means top level braceless struct. Can assert also. Actually, if they are the same, you know what? That is not as easy as that. Okay, we'll worry about the closing condition once we get there. We have to worry about other stuff first. Let's see how we do this. Fields seen. Right, we were trying to keep track of what we had seen. We don't care about that because we're not going to report this information here. We are going to tell people to do the other stuff. Yeah, we should copy this from what we already do in the new version of this stuff. Okay, I'll refill my cup of tea and I'll be back in, I don't know, a couple minutes. BRB. And back. Okay, start token of the struct. I think this condition is too confusing. I think this is better. If you are at the top level and the first tag is .rb, then we consume it. Otherwise, we stay where we are and then we check what's going on. I think this logic is wrong. I think I'm oversimplifying this. Okay, we are at the top level and we are braceless. So we use first token and we want to expect it to be an identifier and everything is fine. We are at the top level and the first token tag is .rb. Then we consume it. We are not at the top level. Yeah, so this is different. This has to be different. This is more like const start talk is if top level and first token tag is dot identifier, then first token. This kind of a conditional assignment, the way it works is that everything can be an expression. So if your if statement has a body that doesn't have curly braces, if it doesn't have a block as a body, then the if you can use it as an expression and this will be assigned to this guy. Well, basically the result of evaluating this expression is going to be this or this. If you put blocks, then the result, like if you do this, for example, now it gets weird because you have to put a semicolon, but let's say that you do something like this along these lines, then evaluating this will result in void because a block evaluates to void unless you give it a label and you break from it explicitly. So this works with everything, also switches. So you can do stuff like const foo equals switch bar, and then there's all the different cases. So I don't know, cooks. If cooks results in true, then that works. But then if you have quacks, I don't know, and this guy instead has a block, then now you can't just, the block evaluates to void. So you're giving a void value to foo, which you don't want to do also because, if this branch returns true, then I guess the assumption is that foo needs to be a Boolean, in which case you will need to do the block stuff. And the idea is that if you're using a block, is because you have to do other stuff. Would break without a label not work? It would not work. You can only break without a label from while loops. Yeah. Sorry, also for. You can break also from for with a value without a label. But like it's only loops that allow you to do that. Very specific way on how it works? Not really. If you think about it, it's like very general. The idea is that all these things, if, switch, while loops, for loops, they all are expressions. But then if the body is a block, they will evaluate to the block. If it's not a block, then they will evaluate to whatever value you put there. And that applies uniformly to pretty much everything. Okay, so I was trying to rewrite this the right way. So if you're at the top level and it is an identifier, then we're good. Else, what do we do in the else case? Else we're either not at the top level or the first token tag is not identifier. Which means that we expect a curly in that case. Okay, I think we're good. Else, so check this out. Now I'll show you an if statement where one branch has a block and one does not. So the if case doesn't have a block. The else case does have a block. So in here, that's kind of what we do. We move this here, and we say that if first token dot tag is different than identifier, then actually no, dot rb, then we complain. Otherwise, we are happy. Or you know what? Oh, check this out. We can make this even better. So what I want to do is something like this. I'll just write it out explicitly so you guys can observe. We can do break blk with t.next. Okay, so this is one way of writing it. Let me double check that the logic is what I expect it to be. So first token, if we are at the top level and we send an identifier, we are fine. We want to start from there. So we don't expect a curly. If instead we are not at the top level or the first token that we see is not an identifier, then it means that we need a curly, an opening curly. So we check for it. And we complain if it's not what it is. And then our start token is going to be the next token, which we expect to be an identifier. So actually this stuff that I got from here, we actually want to keep. There we go. Okay, so we want to do this check, which will be redundant, I think, maybe in some cases, but a little bit redundant, but not terribly so, and it's fine. Okay, so here's how we make this better. We can get rid of this block here. So we can turn this, and then this if can turn into a switch. So we can do it like this. We can do switch of first token.tag. And we can say, if it's a dot RB, note that we're basically inverting this logic. So we're saying if it's a dot RB, I don't even put curlies. We remove all the curlies. And we say that we want to result to this value. Else, and in this case, I do put a block. We do this. So let me remove this other stuff that I cannibalized. So this is the final form. If we're at the top level and the first token is an identifier, then we're happy. Otherwise, we switch on the first token tag and we expect it to be a opening curly, a right bracket. If it is a right bracket, then we continue to the next thing and we're happy. Otherwise, we return an error. And you know what? We can even remove the redundance at this point because we only need to check this token. It's only this token that we need to check that it is an identifier. So you know what? I'm going to do this after all. To avoid a redundant check, I'm gonna move this here, which means that I do need to give it a label and break from it. Okay, let's double check it again. So we're not at the top level, or we didn't see an identifier, so we need to check it. If it's a .rb, then that's nice, but then we need to go move to the next token. If the next token is not an identifier, then we return an error. Otherwise, we're happy. And at this point, we know that this token will gonna be an identifier. Like, we have basically consumed the curly under the right circumstances, complained if the circumstances are not right. So here we should be, there's this invariant where when we reach this point, we will have processed the first token. We'll be centered on a identifier token. So we can even, so that means that we can assert this, which is nice. We can assert that start talk.tag is identifier. And this will help us catch bugs in debug builds and will not do redundant work in release builds. Okay, so once we get to this point, we can instantiate our struct, and now we have to fill it, basically. Is Zig 016 coming out in 2025? No, it won't. Yeah, it's 6 months between releases normally, more or less. So well, regardless of Andrew's state right now, we need the next version of LVM to come out before we'll want to make a release. So yep, and that's not gonna happen before December, I think, or well, before January. Okay, how do we deal with structs in this bad boy? We do a dynamic bit set unmanaged. Oh, in our case, we don't need that. We're fine with a static bit set. Yeah. Static bit set of info fields.len. So this keeps track of scene fields. This is a type init or .empty. Is there, okay, well, how do you initialize one of these bad boys? Init empty, init full. Okay. Init empty. So what we need to do is see what field we're at, process it, and do that in a loop, which is basically a while true. Or although in our case, it should be a for. I think we can do a for. I think we can do this in a for loop. For 0 dot dot info fields len. Okay. Although this could also be a while true, to be honest. I think making this a while true is better. So okay, while true. what do we do? The reason why I'm comfortable with the while true is because we're filling out this static bit set. So this guy basically is going to act as our loop limit no matter what. Okay, so we're filling scene. Okay, we need to see which field we're at right now. It's annoying because there's going to be a loop. It's not, we don't have like a hash map thing. But I don't know, maybe we'll get betterment programming in the future. But for now, it is what it is. So for info.fields f. So for each field, if sd mem.equal. You know what? Oh, there's a nice improvement. There's a nice performance boost that we can do. All right, okay, I'm gonna do the simple version and then we make the cool version. So f.name is gonna be the same as we need to compute the tag. Instead of start talk, this should be like field talk, and we make it var. And we do field talk name equals field talk dot lock dot slice force 1, skip the dot. If the name is the same as name, so we have found our field, and we're gonna break once we get here. And also this needs to be an inline for. Here we're missing a semicolon. So what do we do with this guy? We want to fill it out. Well, we need to check. Is this guy in the static bit set first? Have we already seen it? So this is where I think we can improve the performance of this guy. You know what? I'll go straight up for the performance one. I think we should say this. For info.fields slash 0 dot dot, it's going to be the index. We say if scene dot yeah, actually, how do you access this guy? What is our is set? So if it's not set, so before doing the string comparison, we just check that it is not set. So we're kind of basically making the happy path faster because we avoid looking at the same fields over and over. Once the field is set, we skip it. We don't do string comparisons on it anymore. So this is the happy path, basically. It has to not be set, and at some point we find it. So if this is the case, then we say, okay, then at field result comma f.name equals try serialize inner deserialize inner. Type is going to be f.type GPA source options tokenizer first token t.next top level is false. There you go. So we set the field and then we do scene.set idx. Is it set? I don't know. What's your problem, dude? Is set count, set value, set. Yeah, okay, set. Toggle, unset. No, we set. Okay. So we set this field and we're happy we break these in line 4 and we continue to the next field. How do we continue to the next field? We continue to the next field by we continue to the next field by we continue the next field by consuming one token and expecting it to be a comma necessarily. And we say if t.tag is different, oh, this needs to be talk. If t.tag is different, talk.tag is different than dot comma, we break. Could you say hi to my friends who is watching the stream? His name is Russ. Russ. I see. Your friend Russ, huh? Russ Theodore Code, I guess. I'll go with Russ Theodore Code. Oh, and we need to break outer. So if this is different than a comma, we break outer. Okay, so we do the comma, we break. So we continue as long as it's set. Now there's a problem though. The problem is here. What if we did not succeed? Else. In the else case, so here's the thing. The else case is either a field that doesn't exist or it was a duplicate of one that we already had. So we need another inner loop in this case. This is the cost of optimizing the happy path though, but it's fine, I guess. So we basically do it all again in here. no else, no this, none of this. Okay. A happy path, either an unknown field or a duplicate field. So we don't need the index anymore. We just need the field. Unhappy path. No, what am I doing? This is not in here because this if can fail, and that is not a problem by itself. The problem is when once we're done with the loop, with the for loop. So here, this is it. Yeah, and we don't need to rename this at this point. So we loop again, and we find a match. It's a dupe. It's a dupe. So we can just return duplicate field, I guess. And it's not first token, but it is instead field talk. Hello, Doru. Did Toggle go to lunch? So return error dot duplicate field. And we can assert that scene dot is set. Okay, final else. Okay. We skip scene fields to optimize the happy path. Ba-ba-bam. I see. So yeah, I'm working on a deserializer for my JSON replacement language. It's a bunch of metaprogramming to get to basically see to know every single type in the data file. Think of it as JSON. It's a JSON replacement. So like everything that is in the JSON, how does that map to Zig types? That's the stuff that I'm working on. So so this was a duplicate field. Otherwise, this is a unknown. This is an unknown field, and so yeah, yeah. We don't have surd because it's yeah, you just do it. I mean, there might be something to gain by having like a centralized manner of doing some of this stuff, but yeah, Comply makes it fairly straightforward. I mean, I'm re-implementing this. I have an older version where the language was slightly different and I could have adapted it, but I decided to do it again from scratch because it's not that bad. So yeah. I will definitely introduce new bugs though. That's for sure. No doubt about that. So this is an unknown field, so we can do this. We can return a noun field. Okay. So duplicate field has been reported. Unknown field has been reported. So this should be fine. So these are all the unhappy paths. So we return, no matter what we return. So this is fine. I can even put a nice unreachable here. Just to make it extra clear that we're not exiting from here. Then if we did successfully match, we deserialize, and then we look for a comma. If we see a comma, you know what? It should be like this instead. This should be, if it is a comma, then we break. Otherwise, we break outer. I think this is clearer. Breaking outer means that we're done parsing the struct. And now we have to worry about this is the while loop, right? Yeah. So, okay. Done parsing the struct. See if we have any missing field. So this is what we do at this point. Although before we do this, let's double check that the struct closed correctly. So we need to grab the next field. Const talk is going to be t.next. And we need to say, okay, this has to be either a closing curly bracket Actually, no. Wait a second, because I might have consumed it here. Oh, no. Okay, this is where things get spicy. Because the comma is optional at the end. So there could be a comma. Hey, Toggle. Hello. Hello, Raiders. Hello, everybody. Toggle going to lunch, I guess. Hello, hello. So I'm working on a deserializer. I'm doing basically what Serdi does. Do you guys call it Serdi? Am I pronouncing it correctly? Or is it Serde or something? I don't know. Serde would be like how I would pronounce it if it was an Italian word. Serdi, okay. I'm basically doing what Serdi does. And just implementing this for my JSON replacement language. So it's not too bad. It's just that it has some annoying things, like optional training commas. So right now I need to make sure that I properly account for the optionalness of this training comma. What did I want to say? Oh, I wanted to say this though. So I don't know, Toggle, if you're still around, like if you want to go, or obviously feel free to go. Don't. I won't hold you here. But if you're still around, so I'll show you what I have for Redis briefly. In client.zig. Oh, he was hungry, but he hasn't. He usually says goodbye. If it's well, in any case. It's this stuff. That's what I have. So I don't have a queue of writers, but I have a lock that protects the connection. But here's the idea, which I believe that the Rust implementation also implements, just in a different way. But which also, by the way, it's not very common as far as I can tell. So I think it's it's clever design. It's clever to generally worry about this. But here's the idea. In this case here, what I do is, what people normally do, they lock the connection, write the request, wait the response, read the full response, and then they unlock the connection. No, it's not the same as Python's, because as far as I understand, maybe I misread the Python, but as far as I understand, with Python, they just lock the connection. It's what I just described. Sorry, unless when you say is this, by this you mean not the code that I have here, but my explanation. So in this case, yes, They lock the connection, write the request, read the response, unlock the connection. What is the problem with this approach? That you keep a lock on the connection over the network round trip, which is annoying because you could be writing more to that connection instead of having basically like you could fill the full output pipeline instead of having these hiccups where you stop writing, you stop sending requests until you're done receiving a response. So in my case, I have two locks in a sense, or rather, I have like a lock and a queue, conceptually speaking. So I have a writer lock for the connection where you grab the writer lock, you write your request, but then you release the writer lock and you queue up to obtain a to a linked list of readers. And so what happens is that by giving up the writer lock early, then you queue up waiting for your response to arrive, and maybe there's going to be other people or other like threads in front of you also waiting to read a reply, and everything is going to be in order, so everything will have the right order to do that. But in the meantime, a new thing can grab the writer lock and write their request and queue up as well. And so that way, writing requests does not stop waiting for a network round trip to complete. So I think that does a lot to improve the performance of the client. Rust kinda does the inverse. Rust has a queue of writers, well, a channel, but roughly speaking, let's say it's a queue. It has a queue of writers, and so writers queue up, and I believe that they can write one after the other. Yeah, but they do buffering, which does consume more memory than my solution. But also, you know what? That doesn't immediately answer me. Oh no, that's I guess what they do. Do they block there? Well, yeah. Okay, I'm not clear though on how they get blocked though on the read side. I think it can work. I just don't know exactly how I would implement it. In any case, I think that we're both doing the same general thing, but in different ways. I'm using locks. I have more specifically, I have this. I have a mutex for the writing side, a mutex for the reading side, and I have a linked list of pending structs. And these structs, they point one to the next, but they are stack allocated. So every one of these guys creates a pending instance. They create a node to a linked list on their stack, and then they connect to one another. And the reason why this works is because they all because this thing will not return until it gets woken up by the coroutine or thread queued up in front of it. So there's this whole idea where if you have somebody in front of you, you keep waiting. There's this you wait on a condition variable, and then when the one in front of you is done reading, which you can see kind of here, basically this is the whole parse a reply code. So once a reply has been parsed and it's done reading, then on the way back here on the defer, or as it returns, it grabs the writer lock, grabs the reader lock, and wakes up whoever is afterward, doing a signaling the condition. So I don't know. I don't know if this design is more or less efficient than the Rust one. I think it's competitive, but I don't know. It would have to be measured. And also, there's definitely trade-offs, because I think that the Rust one is 100% buffering more than this one, but it might have fewer things, fewer locking madness going around compared to me. Like less lock contention, that I guess is the technical term. I don't know. We'll see. But I'll need help from somebody to write the Rust benchmark correctly. Maybe I can show you what I have in here for Zig. So this is my current benchmark, where basically in the current benchmark, for every thread, for every core on the CPU, I start a separate coroutine. And for each one of those, I basically start from a random number, and I set a Redis key to that random random number, and then I keep decreasing it by 1. And every time I do that, I also check that the value that I got is the one that I expect. So I also checked for correctness. And then I see how long it took for this thing to do the work. Obviously, if we do that with toggle, we are not going to use random numbers. We're going to need to use something that is well reproducible. The numbers should be different, just so that we make sure that everything behaves correctly as it should. Because there might be bugs in my code, not in the Redis RS one. But yeah, that's the idea. Okay, so here we need to worry about trailing commas and not trailing commas. So if we break here, what about empty structs? What about empty structs? We need to worry also about empty structs. I think this might be a problem. I don't know, maybe. Actually, you know what? Wait. When we see a token that is a comma, we also need to do field doc equals t.next. And we need to check that it is what we think it is. No, this is slightly wrong. So we look at the next token. If it's a comma, then we want also to consume that one. And then we want to check that it is an identifier. So, but we do that with switch, I think. We switch on field talk dot tag, and we say if it's a identifier, then we break the inner loop. We break the inner loop and we continue basically here. You know what? Instead of break, we should do continue. We should do everything in function of outer. So it's more like we continue outer. And so we continue outer. Otherwise, if it's a right bracket or the limiter or EOF, I think we break outer. Else, I think we return an error. I think this is how it should be. Okay, let's think about it a little bit more. We are done with a field. Hey, Jim. Hello. We're done with a field. We see a comma. We look at the next token. If it's another identifier, we know it's another field, so we continue outer. Perfect. If it's a right bracket or a delimiter or EOF, meaning that we are at the end of the document, then we break outer because that's where we deal with the exit condition basically of this struct. And then if it is something else, if it's none of these things, then there's something sus going on. And so we just consider it an error, not first token, but field token. Field talk. You know what? I think we should call it field token. Field token, and we return unexpected. Okay, so this seems correct to me. What if we do next the first time and what we see is not a comma? If we do next the first time and what we see is not a comma, I guess we assign it to field token and then we break outer. I think so. This is another exit condition. Okay. And so what's going on? Yeah. And so when we do this, here we say, here we need to validate basically the struct closing syntax. So it's either going to be a curly or a delimiter or EOF, but the delimiter in EOF is only in the case of a top level struct. So what is the case of a top level struct? A top level struct without a curly is if start token dot tag is different than first token dot tag. I think this might not be right. This might be wrong. It's actually field. See, if it is the same, in all other cases we move forward. Here we return. Here we move next and we break with talk. So okay, so if they are the same, only if they are the same. So if they are the same, then we expect a delimiter or EOF. Otherwise, we expect a curly. Oh, is this start talk? What was this called? No, this is field token. Oh, right. So if first token was a field token, yeah, that's actually, okay, that's actually basically what we're trying to say. Almost. Or you know what? Yeah. I think I'm okay. Okay, we can do better than this. We can do const braceless if first token dot tag is field token dot tag. There we go. We have to do it here because we mutate field token. That's why we can't do it later on. Or wait, if a field token, if first token is an identifier, wait, this assert is giving me inspiration. If the first token was an identifier and we got all the way there, then it is a bracelet struct. Otherwise, we would have complained already. There we go. Let's see. I don't have time right now, but when I do get back to Uscope, well, Microscope, there have been so many changes. I think it's just going to be from scratch for the latest Zig. I see. Yeah, especially, well, if you also want to change how you do stuff, that makes sense. Also, you know what I think? That it makes me think that, okay, let me think if what I'm about to say is dumb or not, or like to what degree. I was about to say that in a debugger, you probably want async IO. But how true is that? Let me think. How true is that? I think that might be true only with regards to the GUI. Oh, well, yeah, if you want to do remote, then yes, some of that. Yeah. So, yeah. Well, the good news in any case is that it's not fully there yet. So if you take a few months before you come back to this, you're not going to miss out on anything. Like, it's going to be better because right now there's good chances that you end up blocking on a missing bit of functionality that has not yet been ported from the old API to the new API. Like right now we have SCDFS file and STDIO file, and neither of the two is complete. So, yeah. Lots of waiting on a child process to break, for example. I see. Yeah. So if the first token tag was an identifier, then this is a braceless top level struct. So that means that we're expecting here field token contains the closing token. How do we do the switch? Well, switch for field token dot tag. If it's EOF or delimiter, we're happy. So okay. Else, it's unexpected. Do-do-do-do-doom. If instead, and you know what? Actually, this could be more like this. There you go. Else we switch token tag, but now the problem is different. We need a curly brace, so RB, in which we do nothing. Else, it's a problem. There we go. Okay, this is actually not bad. Seems a little bit redundant, a little bit, but I think that flipping around the order in which we test this stuff, it's not going to improve the code. Okay, so we have finalized the struct. If we're here, then we're happy, almost, because we might have found that there are some missing fields, so we need to look at that. So we need a iterator. Var scene it is scene.iterator, maybe. Okay, how does this stuff work? Scene, integer bit set, capacity count, set value, set range value, unset, toggle, find. Oh, find first set, find last set. iterator. Yeah, and the options are kind, set, unset. There we go. Want to look at unset fields. Well, actually, we should maybe do this only if there are unset fields. Or maybe there's no point. So um unseen is going to be seen it dot next, or else just return result. And if there is an unseen, oh, this is where things get funny. Oh, this is where things get funny. It. So in this case, we want to return an error. We want to say that there's a missing field. The problem is that there's a missing field doesn't have a corresponding error location. Like an error location is while you want to have almost every time, except in this case. In this case, there's no real error location. I mean, we could point at the closing tag. We could say that field token, like the current field token, is the error location. It's where the problem is. But then we don't say what the missing field is. And that sucks. You kind of would want to be able to say what the missing field is, don't you? But how do you do that? So we could have an extra field basically where we say that missing field is that the missing field is the problem. But then how do people learn what the missing field is? That has to do with schema validation, if there is a schema. I think we need to turn these errors, like we need basically some kind of payload for these errors. Hmm. Hmm. How do we report this error? So we know the unseen, this is the unseen index. And we want to do return error dot missing field. Sure, we can do that. Oh, also, the way it should work is that ZigP CLI based Zig package manager. Please start to support this work. Oh no. So, oh no. Yeah, there is. So, if this was a CLI tool that, oh no. Okay, so personally, based on my opinions, so my personal opinion is that the correct way of implementing this thing is, okay, you like the Zig3 package index and you want to be able to use that package index directly instead of fetching packages from random places. In that case, what I would suggest is that the CLI tool, you basically call like zigp package foo, like install foo, and what that does is that it adds the correct information inside your zig dot sorry, your build.zig.zon, not that it creates a second dependency manifest. This is, I mean, this is, it definitely is. Well, I hope that somebody told Rohan uh, the issues with this approach. I definitely do not want another manifest file in my repos. That is for sure. Okay. If info fields before is different than null, continue. So we're actually fine with not seeing fields that have a default value, which also means that we cannot do this as undefined. Oh, actually, fuck, no, we have to do that. And then here we cannot just continue, but we need to do the setting. So we cannot use the other initializer. So that means that in here we need to do result add field result. What is going on? Can we do this? I don't think we can do this. We do default value. Okay. I think the problem is not really about automating dependency hell. You can automate dependency hell already pretty good if you want with Zig build save, right? I think there are the moving pieces here are different. There are I would say that the main moving piece that does make sense is the idea that you have a website called Zigstry that wants to act as a package registry. So if you like it, if you want to use it, I think it makes sense to maybe make a CLI that helps you more easily fetch stuff from it. It's not necessary because you should totally be able to make do without it. But, for convenience, you want to have it. Why not? So you create a CLI tool. But then the fact that this thing has its own manifest and it has its own version resolution thing, apparently, and whatnot, that part is you're basically re-implementing stuff that the official package manager offers, and that is not good. Or rather, I mean, obviously, you know what, you can do whatever you want, but I would argue that it's duplicating, trying to implement stuff that the official package manager is going to implement. I would say it's a bad idea because you're not going to get community support. As simple as that. And at the end of the day, what even is the point to do that, of doing that? Like, why would you care? Also, here's another problem. Once you start doing this kind of stuff, depending on how you make it work, then what about your dependencies that themselves do not have a ZigP zone file? How do you deal with those? So maybe there are ways. My point, though, is that, I don't know, it's just... I think it's kind of a waste of time in that sense. Is there a way to use a build.zig.zone dependency inside build.zig? Kinda. So your question could be interpreted in a few different ways, but I'll try to answer the most plausible, the most probable meanings of that question. So in your build.zig, you can import your own zone file, and then you can access it as a data structure. And you can grab fields from it. For example, I grab the version from the zone file. That way, this version then will end up inside the output of the version subcommand of this CLI tool. Okay, so that's your own zone file. Now, what about dependencies? Can you use dependencies? Kinda, yes. In a project, so this is the build.zig of my JSON replacement language. You can see here that I do this. I do pubconst Ziggy, and then I import root. So what this does, and this only works because Ziggy does not have dependencies, or rather, the CLI tool does have dependencies, but the core business logic, the parser, basically, does not have dependencies. So because of that, I can import the root file and it will work because the core library will not attempt to depend on anything else other than a standard library. And so I can re-export it here in my build file. Now, if you import, like if you depend on Ziggy, so if you add Ziggy as a dependency added to your own zone file, so not in this file, but in your own build script, then you can do this. You can do const Ziggy equals at import wait, how did it work? Fuck, I'm blanking. How did this work? Wait. You can access your dependencies as long as they themselves are dependency-less. Let's go to Zine because I do it in Zine. How does it work? This gives you yourself. Wait, I had it. Oh, I don't do it anymore. Oh shit. Wait a second. So How did that work? Okay, you know what? I haven't done it in a while, so that's why I'm kind of brain farting a little bit. But I think it works like this. So here, Zine. So now I'm looking at a different build script, right? The one from Zine. Let me find build. Okay, so here I have Zine. And Zine, if you look at its zone file, depends on, well, a bunch of stuff, including Ziggy. So the way it would work is that here, I think I can do this. Const Ziggy equals at import Ziggy. The reason why this add import Ziggy works is because I have Ziggy in my depth, but this does not give me the full dependency. This imports the build script of Ziggy. This imports build.zig in the one from Ziggy. So here I can do Ziggy dot I guess Ziggy, because it's named because this thing is named Ziggy. But I can access these definitions that are in here, which in this case are not that many. They're just it's just the build thing itself and pretty much nothing else. So and because I re-export from my build script the core logic, then Zine will be able to access it. Actually, you know what? I think I remember now. So you see how here Zine exposes stuff like website, like it exposes things that you can do, like it exposes basically like recipes that other build scripts can use directly. And we do this in the Zig website. So I think that here we will see import Zine in the Zig websites build.zig. Yeah, there we go. Here we import Zine. And if we look at where we use it, you will see that here I'm using zine.build asset. So I'm referencing definitions in the build script. Okay, so to repeat one last time, if you have a dependency, you can just import it, and that will give you the dependencies build script. If the dependency is in turn dependencyless, like if it can be used without it needing to go through a build process, or rather the parts of that library that don't need to go through a build process to work, then those can be re-exported by the build script, and then users will be able to use them at build time. But obviously, if your dependency in turn has other dependencies, so in turn it needs to go through a build process in order for it to work, then it will not, that stuff, you're not going to be able to make it available at build time. So I hope this answered the question. It's kind of it's cool, but it's also limited, but it makes sense for it to be limited, because otherwise you're going to have like a fractal amount of different build times that happen at different moments, and then diagnosing what the heck is going on would become a nightmare. And I think it's nice that also like it's something that rewards dependency-less code, because if your thing is dependency-less, then it's more versatile because it can also be used at build time. And I think naming this thing Ziggy is not a good idea. But, oh well. Okay. Makes sense? Awesome. I was worried that I started rambling a little bit too much. So duplicate, unknown. So with this, we should have done everything that we needed to do for the struct. All right, the only problem is this missing field stuff. This missing field stuff. How do we explain what is the missing field? I guess we can add a thing for this. Error lock. Okay, there we go. The missing field. Okay, we should have implemented structs. That should leave us now with pointers. The only thing annoying about pointers, I think, is going to be pretty much just slices. Sorry, strings, basically. Strings are going to be the only annoying thing. Everything else should be fine. Yeah. Okay, so what are the possibilities for a pointer? What we care about is size. Yeah, what we really care about is pretty much only size. Address space, I don't know. I think we can leave the rest maybe a little bit more underspecified. We'll figure it out in case there's a problem in the future. But yeah, the question is size and size, pretty much. The first thing that we do is switch on size, and then it's gonna be dot slice. Let's see if it's still uppercase. Is it still uppercase? No. One many slice C. One many slice and C. I think that dot C and dot many both we can handle in the same way, which is a compile error. Which we can put at the top. Okay, so the question is 1 and slice. Okay, pointer to 1. Let's deal with a pointer to 1. Pointer to 1 should be easy. Pointer to 1 means that we do it like this, I think. We do const. Actually, can we just return? No. Okay, we need to do this. We need to do const ptr is going to be gpa.create one info. I'm guessing it has a child field, does it not? Come on. Oh no, it does not. It's just an enum. It's okay. Child is separate, so we don't care about this. Okay, so we do info.child, create info.child, ptr of type t, and then we do ptr.star equals try deserialize inner. Type is going to be info.child GPA source options t first token false. Actually, wait a second. Is it false? No, this is what we were given. Yeah. Actually, even in optional is what we were given. Okay. So we deserialize inner and then we return PTR. That's it. That is easy. Slice is not as easy. Slice. For slice, we need to worry about what the child type is. We're gonna switch. Actually, maybe we can switch on the slice type itself. Wait, does that make sense? How are we doing it in here? Ba-ba-ba-bum. So if it's a slice, we look at pointer child. If it's a slice of U8, then we do parse bytes. Otherwise, we do parse array. Yeah. Yeah, that makes sense to me. It makes sense to me. So we do. Okay, if it's a slice. I think we do need a separate function for parsing strings, though. We do try something like parse string. What do we do? What do we call it? Oh, I guess this is a. Okay, let me think about it for a second. Is this a return? Yeah, return parse slice. Well, parse string. Or you know what? Parse bytes. Parse bytes. We need the pointer type in full. We need GPA for sure. We need source. We need the tokenizer, and we need first token. Okay. Otherwise, we parse the array. I mean, I don't know if a function is necessary really, but okay, parsing the array. How does this work? I think we can copy some of this code in here. You get type info t pointer. Square bracket. We create an array list unmanaged. Oh. Yeah, we create an array list unmanaged. That's how we do it because we don't know how many items are going to be there. Elements, or you know what, buff. This is going to be an array list of info.child starts empty. And basically we keep doing this. First, we validate the first token. If it's different than right square bracket, then we complain. Unexpected token. Otherwise, I guess this is another while true. While true, we want to do buff try buff.append. GPA, try serialize inner, deserialize inner. Type is info.child, GPA, source, options, T, first token. First token is going to be T.next though. And top level. Top level is going to be false. Okay, so with this, we try to grab one element and put it there. And then hey, two-step. You're right. That's a left square bracket. Thank you. Totally right. Okay. So we append an element and we expect a comma, which might or might not be there. So if, well, we need the next token, right? So const talk equals t.next. If talk, I guess we switch talk. If it's a comma, we continue. If it's a right square bracket, then we want to break, else we want to complain. If it is a right square bracket, I mean, we're done. We're happy at this point. I guess the only problem is that we need to pray that this slice doesn't have weird requirements other than maybe a sentinel. So let's look at if it needs stuff like a sentinel pointer. Okay, sentinel. Well, return fine, just return. Otherwise, return elements not to owned slice sentinel. Yes. So with this, we respect the sentinel. I mean, this is it. We're happy. This was actually less annoying than I expected it to be. Okay. The only super ugly part now is going to be dealing with strings. Strings are going to be annoying as fuck. But that's the only thing. Doo-doo-doo. What do we have in the old code? It had a bunch of cleanup in case of errors, which we don't have right now, which we should get back, sure. Oh, here's what we had. We had a bunch of delegation code for types that would know how to parse themselves. That is interesting indeed. That is interesting indeed. That is interesting indeed. It really makes, you know, this whole stuff really makes me wonder how much am I gaining by not building an AST? Because if I have an AST, this is so much better. This would be so much better. I'm really wondering why not just do an AST every single time? I guess the assumption is that this version would be faster, more performant. That is really opening my mind. But let's continue with what we're doing. Okay, so we're missing some stuff, but nothing crazy. Let's look at parse bytes. This one is gnarly. Yeah, we look at the token. And we need to peek. Yeah, we need to peek. Are you trying to copy Saturday's macro? Is that what you mean by AST, like the Z version of proc macros? No, I'm talking about. So what I'm doing here is, you know what? Give me a sec. I'll do something that I should have done a long time ago. Okay, so here's what I'm doing right now. I have two implementations. One is the AST. AST takes your bytes, so the document, right, loaded into memory, and it turns them into an AST. That's ast.init that does that. Then I have deserializer. I'm going to call it DS. Deserializer takes your bytes, turns them into tokens, one at a time, and then puts them directly into your Zig types. So the AST approach, one, basically has at some point an allocated AST in memory. So somewhere in memory, you have something that looks like this, kinda. While the second one doesn't do that. It does need an allocator because sometimes you need to allocate stuff, but it skips entirely this process. And instead, it immediately stuffs your tokens from the document into the resulting type. An alternative approach would be that instead we always go through an AST. So instead of having this deserializer work directly off of tokens, what we would do is that we would have an alternative deserializer. I'm going to call it, I don't know, ADS, alternative deserializer, or AST deserializer, whichever way you want to think you like it. And we could have this thing go from bytes to an AST, and then have the AST go to a Zig type. The downside is that you have this data structure in memory that occupies memory that you could do without. Like, you can implement a deserializer that doesn't go through an AST. That's what I have right now. But the advantage would be that if we have this guy, error reporting becomes so much more expressive and precise right away. Or rather, sorry. Let me put it this way. Usage of this library becomes easier because you always have an AST, and so this function would be able to immediately give you it would immediately be able to give you precise information about the error. With the current approach where we skip the AST, we're not able to give you precise, reliable diagnostics right away. And so what happens is that the current approach in my DS is this. The happy path is bytes to tokens. I'm just gonna say talk to Zig types. And the unhappy path is in the unhappy path, we give you a shitty error, an error that doesn't know the full context, because we're already seeing tokens. We don't have an AST in our mind, so we don't know how well we're doing. And so in the whole structure, because we haven't paid the memory to keep track of that information, so we give you a let's call it like a not a temporary, but it's like a I don't know, like an unvetted error. Well, we give you some kind of imprecise error. Man, my calligraphy is horrible on this thing. My excuse is that I'm also not in a comfortable position, but calligraphy is bad. In any case, we give an imprecise error, and then we're telling you, okay, so this imprecise error you cannot trust directly. So first, in this unhappy path, the first thing you want to do if you want to provide good error reporting is that you need to build an AST. You build the AST, and then after you build the AST, you see if that returns any error. And if it does, you report the error from the AST. If everything goes well, there is no error, then only then you can trust this imprecise error to be telling you the truth. And so only then you report that error. It's weird, right? It's a weird way of using the library. But the reason for this, the reason why I'm going through all this trouble, is because this way you don't have to do this on the happy path. You skip the AST on the happy path. So that's what I'm doing right now. But it does come with some downsides, like with some trade-offs, basically. I don't know if the drawing tablet has helped at all with this explanation, but oh well. Man, I don't even have an escape in here, do I? I have slice. I don't have an escape. You know what? Maybe an escape instead of an allocator should accept a writer. Then maybe would make things better. You know what? I guess for now we can just do this. But this might not be compatible with our thing with parse bytes. Also, there's the problem of copying stuff. So we need options. And then we care about the sentinel. So we switch info dot sentinel. Okay. If info dot sentinel return GPA dot dupe z. Yeah, dupe z. Dupe z type u8. Dupe z u8. The original thing, the memory is first token dot lock dot slice source. This is correct. Else what does the Z stand for dupe Z? Z means yeah, zero sentinel. You can see that dupe returns a slice. Dupe Z returns a null terminated thing. So in this case, the reason why I care about this is because the user might have specified that they want a null terminated string for a given field, and so I need to if I decide to not support that, I can do that, but then I probably should put a nice error message, or I support it, and to support it, I need to explicitly copy the string because this string that we have in the source code will not have a null terminator at the end, right? It will have a comma, like it will have a closing, it will have a closing quote, and then we'll have a comma. So to make sure that to provide the user with a slice that has a null at the end, I'm gonna need to copy it necessarily, and dupe z does that for you, basically. Okay, so if we copy always, or you know what? I think it's kind of like the opposite. We look at if it wants a sentinel, and then after that we look if we copy always or not. So if info to sentinel, if there's a sentinel, we do something else. We look at copy strings, I think. So if it's sentinel, we do this. Otherwise, if there is no sentinel, also this is dupe z. Wait a second, this is dupe z, but this is not the. We don't know if the sentinel is 0 or not. The sentinel could actually be something else. So we need to copy this code and do it ourselves. Okay. Also, this is not source. Oh no. This is not source. Fuck. There we go. Should be s instead of colon 0. The only place where I have colon 0 is the input source, so that is fine. The colon s whatever is encoded in the return type. Oh, but you're right here. I didn't see this. You're totally right. Yeah. Thank you. I completely missed that. To always 0 to unescape. So we need to get unescaping going. This is so annoying that we're not doing it. It's so annoying that we don't not doing unescaping. So, well, anyway. Unescape support. It's gonna be such a pain in the ass, but we need that. Okay, so this is one case. There's the other case where parse bytes. It's the line string case, which I'm going to copy. Would it be easier to use GPL lock sentinel? Is that a thing? What? I stole the implementation from DupeZ. There's also unlock sentinel. Interesting. Yeah, it would definitely help. Well, what do you know? Oh, but it wants a comp time sentinel, which is fine. Okay, we can comp time sentinel certainly. S. And then we mem copy. Like this. Okay. Okay, bytes line. And we're missing peak. We're missing peak. Dip sentinel. Yeah, that would make sense. Okay, the only thing that we need to worry about now is this concept of peaking. Does the tokenizer have a peak? There's no peaking in the tokenizer. We need to do it externally. So how do you peak? Basically, before you call next, you you want to save the state of the tokenizer. You know what? Let's just do this. We make a peak function. You know what? You should return a tag directly. There you go. There you go. We could have also used a writing allocating writer. I guess they both would serve the purpose. Okay, we're missing the else case. where we should complain. Then where is this guy being called from? From here, it wants also options. Okay, let's see what problems we have. User identifier elements. Are you sure? Oh, I called it buff. Okay, so far so good. This code is missing tests, so it's 100% totally broken, without a doubt. Do we have tests in the parser? We have some tests. So we should be able to port these tests to the new implementation. Holy shit, okay, we do have tests. Okay, fine. Okay. So we need to now take these tests, update them, all of them. Jesus. Okay, we update all those tests to the new implementation, and then we add the missing pieces. So we're missing delegation in case that the type has um, special fields. Oh, you know also what we're missing? We're missing the concept of ignoring fields. There's also ignored fields that we're missing. Um, and then what else? Yeah. Yeah. It's going to be some work. So here's my plan. My plan is going to be I'm going to take a very quick break. I'm going to refill my cup of tea. I'm going to inquire about lunch plans. And I might take a lunch break at some point. We'll see. But I'm not going to interrupt the stream. I'm just going to, disappear for like, I don't know, 20 minutes. And then we continue. Did you see the Fuzzing Smith? No, I did not see the Fuzzing Smith VR. Okay. I'm looking forward to take a look at that. Although fuzzing needs so much stuff before the fuzzing smith. Sure, that's also not a good piece. A good puzzle piece, but man, there's some much more infrastructure that it's needed. Oof. Okay, I'll be right back. Okay, I'm back. There's no music change. Okay, let's start fixing tests. And you know what? Let's do it also like this. One test at a time. Case. Arena state. Arena. The serialize, right. So in GPA case options. Okay, let's see how this test stuff goes. Missing start field copy strings. Guess we can give it a default value. Nothing named comptime int. Comptime. Compete me. Serializer options, white space has no member named space 4. It's space underscore. Oh, we're missing type, void, null, and vector. Right. So void, null, type void, null. We're missing vector. Can we do both array and vector? Vector has len and child, which is the same as array, is it? Almost. Array also has sentinel. Vector does not. Oh, an array can have a sentinel. Interesting. Okay. So since an array can have a sentinel, we need to worry about that. So we do. Oh, but we're kind of worrying about it implicitly in a sense. Now that I think about it. So wait a second. I think those can be like this. Okay, the two types are not going to be compatible. Oh wait, is it complaining about serializer now? No. Oh, it's down here. Okay, never mind. Okay, so it is fine. What? No field name dot rb. Yeah, it's dot rb. Identifier. Expected type font const. No field name delimiter in token tag. Really? Oh, EOD. Okay, there's a problem with the error set, which makes sense. Values of type. But index value is runtime known. Huh. So we cannot use an iterator. We have to go one by one. That really sucks, though. It means that we need to make an array of booleans. We cannot use this thing. That's unfortunate. Hmm. I don't think I can do this without um, turning this into an array. but with an enum set. I think I see what you're saying. Like, so here's the problem though. I can do that, but the problem is that this forces me to do a linear scan over the bit field. And so that means I believe that I will have to do the masking over and over. And like there is I think the iterator does better than that. I might be wrong, but I think the iterator does better than that. But you're right. I could do this. I could turn this into a indexing into that thing. You know what? Fuck it. Okay, I'm sold. Let's do this. So we keep this as is, and then down here, instead of a instead of iterating like this, in line for info.fields 0 dot dot. Okay, that should work. Try control flow inside runtime block. I think it works if we do this. No, it does not work if we do this because we want to continue. Okay, never mind. So we just have to phrase this differently. Let's see. No missing field. Missing field name. Also, you know what we're missing? Opts out dot error lock. This needs to be field token dot lock. Okay, what's the next problem? Switch on type, first token, yeah, for 20. It's type pointer tokenizer found const tokenizer 459. Oh, yeah. No field name sentinel. Yeah. Okay. Serializer is broken? Oh, it's because we changed the default from being we changed the default in serializer. Yeah, let's go update those tests. Okay, let's see how do we do. Errors wise. Two tests failing. Okay. So one is in the serializer. Test union. It's a test called union. There we go. Wait, what's the problem then, man? Oh no, this is telling me the wrong information, I think. I think this guy is pooping itself. This is not the right name. This is bad. This is sometimes telling us the wrong name. This is the right test, but this is the wrong name. Oh no, never mind. It is correct. It's the first one that I missed. There we go. How many hide? There we go. Okay, this serializer test struct basics failed because we got an unexpected token. We think that we got an unexpected token. Okay, back to the deserializer. Hmm. I don't know. What's your problem, dude? In parse bytes returned unexpected 452. Oh, yeah. You know what we're missing? We're missing equal signs. Oh, you know also what we are missing? We're missing Ziggy dictionaries. Shit. We're also kind of missing Ziggy dictionaries. Okay. So let's see. We look at the field. Everything works. We find it. We find the field. Then the thing that we do first is next. There we go. Let's see if that makes it any better. Huh. Slice gives us the token including quotes around it. Right. This is the general problem around not having escaping implemented. That sucks. There must be something under Zig in the Zig namespace. I mean, hmm. Okay. Returns a formatter for escaping a double quoted Zig string. This, I believe, is what we use in serialize, right? Yeah. But we need the inverse. Uh, there we go. Print the string as escape contents of a double quoted string. Oh, is this the same as this? Wait, what? Wait, where's the inverse operation? There's string literal. Parse chart literal. Parse escape sequence. Parse write. Parses bytes as a Zig string literal and writes the result in the writer type. There we go. It's parse write. That's what we want. Is there also parse alloc? Yeah, okay. It's either parse write or parse alloc. I mean, they're kind of the same thing. Okay. So instead of slice, Okay, this way we should have something that actually does what it's supposed to do. Parse bytes. Oh, that wants a bunch of stuff. What? Oh, this guy has a complicated error set. Invalid literal. Yeah, I think we should be able to assert that we don't get that. Okay, test passed. Top level curlies. So we need options. Parse key must become deserialized. So this should be fine or not. Error unexpected. Why? Okay, let's take a look. Struct. Oh, I know why. It's the example that is wrong. We actually have a dot now. That's the new syntax. There we go. Succeeds. Succeeds. We succeeded. Oops. What is this one? Optional comma, right? We passed the test already. Okay, let's proceed. You don't identify diagnostic. Oh, this guy wants diagnostics. Wait, fuck. Where's my case? Oh, it's because it's constituate. Okay. Success. Date. Right. Um, but this doesn't exist anymore. So I think I should just nuke that, or we turn it into a union test. Values of type. Unit field must be com time runtime. Okay, 169. Inline. There's an extra control flow reaches in the body. Error function with non-void return type. Oh shit, we have a fall through. Red alert, we have a fall through. We have a fall through in, you know what? Wait. Oh my god, this fucking thing is busted. Unreachable. No fall through. Illegal. Mm, okay, so our problem here is that in the union case, in line 4, right, we're looking for a field that matches. Oh, also here, we're looking for a match, right? What is it that we're missing? Well, we're missing the case where we don't find any, and this is a unknown field. That's what we're missing. And this same thing we're missing also down here. Expected type constraint found U8. Oh, the signature is completely different. Allocator? No. No, this is right. Allocator. Oh, the element type, right. So this is wrong. This is info.child. And okay, is this better? There we go. 51 tests passed. We're blazing through this stuff. Unreachable now hides compile error. Oh no, you're right. It should be comp time unreachable. There we go. Comp time unreachable. So basically, I want to make sure that the fall through is impossible. So I was wrong because you're right. It was wrong because I was missing comp time, but my goal was not to hide. My goal was to enforce that fall through is a compile error. Nothing named int in token tag. Integer. Okay, success. Right, we did pass. Well, the good news is that thanks to all these tests, it's not going to be more broken than it was before. That's for sure. We don't know if it's going to be correct, but it's not going to be more broken. Or rather, if it is, it's broken in a way that it's not covered by the tests. So there we go. No field name Sentinel. There we go. Training comma failed. Aha. We borked array. Let's take a look. Yeah. We obviously did it wrong. Why? Because if there is a... Okay, no, actually, no. Give me a sec. If there is a trailing comma, then we end up going in deserialize inner. So I think we need to pick in this case. If there is a trailing comma, we need to say, okay, then what is next? If next is... Well, I think we need to pick if peak is a right is different than a right square bracket, then continue. Else break. Is this better? No. Trailing comma still fails. Why? Hmm. Have you heard the other day how to use Kcov with some text in Zig? I think Squeak had a blog post on how to do that in the past. I think because it's kind of related vaguely, but it is related to fuzzing, and I think that's where Squeak started ages ago. Though I have this weak memory. Okay, so why am I fucking this up? Expect this to be a... Oh, you know what we're missing also? Like an empty array. Look at this. We don't even make it work for an empty array. Okay, so this there's no peeking. If there's a comma, we continue. If there's a right square bracket, we break if we are at the end. But then, and if we're not at the end, then we complain. But then, here we need to check. We need to say, if next, and I think we need a length mismatch error also in case of arrays. So we need to do if next dot tag is right square bracket, then we're preparing to exit. But then if idx is different than r.len -1, then instead we return error.length mismatch. And we do set this to the next token. There we go. Otherwise, we break or we return. Oh, I see what's going on. Look, also, where's the... no, I actually do not see what's going on. On exit, we do maybe RSB. Yeah, you know what? I think this outside condition is bad. Yeah, I think this outside condition is just bad. This is kind of annoying. Okay. No, I take this back. I'm not sure it's universally bad, but definitely as we get inside, the first thing we need to check is the exit condition. So if there's an RSB, return array. We return the array in this case. Otherwise, we set elem to this guy. Look at the next token. If it's a comma, now this is more like a peek. We peek the next token, and if it is a comma, we continue. If there's a comma, we consume it. And we continue. And I think we switch. And in the comma case, we do some of this stuff. If we see a right square bracket here, what do? We continue. Else we complain about it on next.log. But we might continue. This is not correct. Still, this is still wrong. God damn it! Because here we would check for the square bracket. I guess we would return. Okay, but here we see a right square bracket. Then we want to break. But if we want to break on that peak, then what even is the point? We might as well just do the return thing. You know what? I really think that this one outside should go. We make it contain unreachable, and then we deal with this in here. So this means that oh, but then there's also the else case. Okay, wait a second. No, I take this back. I don't think we can. Okay, one last time. Let's see. I did read Squeak's blog about it. For me, the missing pieces were the build option to use LVM. I see. Mm-hmm. Yeah, the x86 backend uses dwarf v5, and it specifies, and it uses it identifies Zig as Zig, and I think it might generate some debug info stuff that is that the tool doesn't understand. The tool only understands probably C, or rather, I guess the language code, like the debug info output changes based on the active language, and the tools that consume that information need to have their own implementation for each language, I guess. Or I don't know, maybe somebody's doing something weird in our other in the debug info generated by the backend. I don't know. So okay, can we get this freaking array thing right? We look at the opening tag, then we start looking at the array, which might be empty also, by the way. What if these might also have length 0, for example? So if it has length 0, we immediately go to the end, and that works. Okay. They say that it has length 1, but we immediately see a closing tag. Then if the length is a mismatch, we complain. Otherwise, let's say that the length was not a mismatch. So we did one round and everything went well. Second round, we find the closing tag. We see that the lengths do match. We return the array and we're happy. Okay, we keep looking at this stuff. We look at the comma. So the problem is here right now. This is the bug. Because here, we see a right square bracket. We don't know if it's correct or not. Like if we're going to go up here, or if we're gonna go outside. Actually, we can force this. This should be a break, so that we make it clear that we're gonna go outside. But if we do this, then there's a length problem, and not only there's a length problem, but also there's this check here. So how do we do this? I guess this should be like this. Else. No, that makes no sense. Fuck. I guess I just need to duplicate these checks a bunch. These length checks a bunch. So we see a right square bracket. Okay, we don't break nor we do the other thing. We just immediately say, okay, wait. Find a right square bracket. Are we at the last? Are we at the very end? If not, return error link mismatch. Else return the array. Okay, so this all works. Now the only thing that we're missing is the fact that this outside check is only for length 0, and it freaking sucks. Make it comp time unreachable, and then here we do this. There we go. If expected length is 0, we immediately want a right square bracket. Otherwise, we're going to complain. And we're going to say it's a length mismatch. There you go. Okay. Are we happy now? We're still not happy. $150. Oh, wait, what? What the fuck? We're returning unexpected while deserializing a number. Still in array trailing comma. I guess we passed down the wrong token or something? What? That that weirds me out. We enter the array. We look at the first token, which we expect to be oh, wait, I know what this is. I thought that we were deserializing in an array, but wait, we might not be deserializing in an array at all. Yeah, we're deserializing in a slice. Fuck, array doesn't. We're not doing that. We're doing the slice one. Fuck. There we go. Oh shit, it's the same thing and I'm fucking it up. God damn it, man. God damn it. Look at the left square bracket. This is a while true. Actually, the fact that this is a while true kind of makes it better. We want to mirror the array thing. We want to kind of mirror the array logic. So the first thing that we want to check for is if the next token is a right square bracket. And in our case, we don't complain. We're happy with this. So we break. So this is the first thing that we check. Next is what we pass down. Then we peek. And if we peek, then we just do, if it's a comma, we do t.next goes through, and we continue. Otherwise, we return unexpected. I think this is kind of it. It's as simple as that. As simple as that. Reach unreachable code. Oh, because here we break. We don't break. Oh, we're missing the fuck. I deleted some code that I should not have deleted, huh? Yeah, okay, we do break here. And it's fine. That's my bad. Array basics failed. I broke the array stuff. Why? Because we're hitting unexpected in 1, 2, 3. Right. What if it's not a comma? Oh my god. Yeah, this needs to be a. Also, wait a second. This is a slice. I see. Well, this is a switch. In the comma case, we do this. There we go. Okay. Expected type of blah 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 found. Oh. This is interesting. This cannot be returned. This needs to be returned. Try. There we go. Can get rid of this. Unions. Unexpected. 497. We got into parse bytes on the wrong token. Really? Oh yeah. Well, look at this shit. That's not a thing anymore. I'm taking it out. Unknown field. Okay, this is interesting. Remote local. Unknown field? Are you sure, my friend? Date, remote, local. Uh, that is correct. What's the issue? Remote and then local. Local. Remote. Local. Oh my god. What? What? How? Testing remote versus local. Oh, there you go. The problem is that I gave the else to the if instead of giving it to the inline for. There we go. That works. Unexpected. Oh no. Interesting. Oh, actually correct. Okay. Oh, this is gonna be nasty. And these are that's information that I'm not filling, unfortunately, that I should be filling. That is information that I should be filling. Yep. Okay, let's go implement this. So we're not gonna pass this test. No fill name front matter lines. Doc. It should be doc.end offset. Or just end. Okay, so problem is we get unexpected. Okay, so we don't even parse correctly, which does make sense because this is. So I changed this. This kind of wants you to start after the opening thingy. And so this should be case. Should be like this. Which does return unexpected. That makes sense. Option dot delimiter. It's dashes. Okay. So let's see what's going on. In a top level struct, I think my struct code might need to be reworked though. Hmm. if we're at the top level, we need to complain about missing fields. Which kind of makes you want to have some kind of... Oh, that's why probably I had finalized struct, huh? As a separate function in the past. We want to do this, basically. We want to finalize the struct like this. So to do this correctly, then scene must go all the way to the top. Then this must go into a dedicated function. Info scene. That's it, I think. Hey, Diablo. I don't know if the rest is correct, but I don't know. Well, how are we doing here? That's std built-in type struct. Address of operator always returns a pointer. Right. Oh God, what am I doing? Okay, we're back to error unexpected. Okay. So if instead of a comma, oh, here's the problem. I found the problem. Fuck. Yes, I knew that I needed to change this logic because I had to change it elsewhere. So fuck. 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 So here's how it works. In our while true, before we grab the name, we need to check. We need to switch field token. And here we cannot assert this. Or rather, we can. The fact that we can assert this is dumb. Because we need to check this first. So switch token dot tag. And in, let's see. In right bracket EOD EOF, we break outer. Else, in identifier, we continue. Else, actually, let's do it this way. Else, we need to complain. There we go. If field token is an identifier, then great. If it's a closing bracket, then we finalize the struct. Otherwise, we complain. Now, this thing up here, I think it's fine. Fuck it. We'll leave it there. Okay, so we do this check here. So it means that down here, the comma thing has to be different. This has to turn into a peak. And I guess this is a switch peak. Is it a switch peak? No, it doesn't have to. We discard the comma if present. Otherwise, we do nothing. So, what do you think about this? So if there's a comma, we skip it, and then we... Oh, and then no matter what, we break outer. No, we continue outer. So we found a matching field. Okay, we process the field, we eat the comma, and then we continue outer. If we continue outer, we're looking at field token. So that means that we need to do token equals next to no matter what. Okay. We break everything. Okay, so far we haven't broken everything. Good, I guess. We're still passing previous tests. We're still only failing the front matter one, which keeps getting into an unexpected state. Okay. Well, let's see what is this problematic token. Show me. Invalid. Wait a second. Oh, fuck. Yes, of course. That's on me. Yeah, there we go. Okay, so now we succeed, but we don't set those fields. Okay, so how do we set those fields? I guess here. Extra 35, found 32. Interesting. Interesting. So lines matches, it's bytes that doesn't match. I guess the original one wanted something different. Wait a second, it wants that to be case.len. Oh, right, because that's the old one. Case.len minus .len. Okay. Extra new line. Okay. Expected for found 3. Oh. This is Lyle from YouTube. Sorry, Lyle. Did the chat break on YouTube? It did. I'm sorry. If you created a var, there was a struct that had each parameter set in the struct. Could you call the var You need to use those parameters. Okay. If you created a var, there was a struct that had each parameter set in the struct. Could you just call the var when you need to use those parameters? So you're saying something like there's a function that accepts foo and bar as arguments, and you want to be able to call your function kind of like these. Is that what you're talking about? Somehow. Sorry, I'm having trouble deciphering what your request is. And so this test is stupid, and I don't think we should even pass it. I'm gonna delete it. Let's see. Press extract no training comma front matter. Fine. Okay, it seems like we're doing fine. Oh, this is another one of those weird extra new line ones. I'm gonna delete it. Struct front matter. Expected 6, found 4. Okay, this is a good test. This is a good test that we're definitely failing. Okay, so here's the problem. The problem is that so we can't do it like this. So here's the problem. The problem is that when we get here, we don't know if we have we don't know if we have consumed everything in the document or not. There might be some extra data, some trailing data. Like there's one struct instance, and then there's blah 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 blah. Blah 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 is a syntax error. So we need to detect that. And to do that, we need to ensure that we drained the tokenizer. Now, how does the tokenizer deal with encountering EOD? Oh, I know what it does. It returns EOF afterwards, I think. So we basically need to do this. If t.next if EOF.tag is different than EOF, let's call it end. Switch end.tag. EOF. Oh, okay, that's fine. EOD. That's also fine. I guess it's EOF or EOD. Else we need to complain. And this breaks test struct front matter, which I think is the last one. So this is still broken. That surprises me. For example, let's see var parse struct allocator parent2 function foo equals parse. What is EOD? End of document? Yes, it's end of document, and it only is returned as a token if you specify a delimiter. So in the tokenizer, when you instantiate it, you can say that you want to consider triple dashes, triple backticks, or a closing script tag as your as a and documented delimiter. Which I don't know, maybe it's a bad idea. It's something that I wanted to experiment with in this iteration of Ziggy. So it should make it easier to parse Ziggy documents nested inside other documents. And so the tokenizer will give you EOD when it encounters that thing. Okay, so I know what is going on here. The problem here, I think. Actually, you know what? I'm not sure what the problem is, because this should be fine. We should be passing this one now. Yeah, you know what? I think it's the same problem that... Is it 565? Yeah, it's 65. The problem is this new line here that we are not... Yeah, but you know what? I want another one. Another one. I want another one of these where it says from matter plus markdown. Blah, blah, blah. And this should say 5. And this should not say case len minus blah, blah, blah. But it should say, I don't remember. Let's say 10. Let's put here 1. Please suggest the right values for this stuff. Oh, fuck, I can use constants. $74. Okay, so this is 74. So this should be 74. And it's not gonna work. Or maybe it will. Found 89. Yeah, that is wrong indeed. And that is because the tokenizer... Do I need a special branch where when I encounter EOD... I guess this is... Yeah, that's how you do it. Okay, now instead, let's watch this fail instead. Okay, this one 31. Okay. What should this other one be? 3. Perfect. And now what should fail? Yep. Okay, the problem is in braceless struct. Because in braceless struct, we need to be careful. Or you know what? Actually, there is a way of making this work nicely. If we see EOD, okay, we don't need to add anything weird there because we check it here. Okay, are we better now? Expected 31, found 5. The doc end 5? No. Doc end 5? That's not it. What am I missing? I think 3 is correct because I think it counts because we are slicing from right after the opening 3 ones. So this is a new line, and then there's 2 inside the document. But you don't want to lose this new line, or rather, I will admit that it's kind of a finicky API. But the reason why I'm making it this way is because I've already done this work inside of Zine, and I've seen the problem in the past where I wanted to parse the front matter and the document separately, and then the offsets wouldn't match, and because I would by mistake like lose this new line. So in the end, it's finicky, but you can decide how you want to fine tune this based on how you slice this thing. That's the idea. So We're getting, I think, we're getting bad numbers. Also, why am I getting 5? Oh, because this is EOD, comma EOF. But that still does not answer. This is not still not it for sure. So actually, you know what? It doesn't matter. This can be done unconditionally. We also have to do it down here. Okay, so this needs to be done outside. Still will not work. Also, wait, we regressed stuff? 62 out of 65? Oh no. We regressed a bunch of stuff. Why does it keep finding 5? That's not good. Have a nice day, Two Step. I think. Oh, this is it. Field token, not first token. Kind of a silly mistake. There we go. Okay, now everything passes. Okay. So we have restored the previous functionality, at least as far as our unit testing is concerned. So we have this. The only thing that remains is to change this to the serialized leaky, I think. There's a Ziggy document string into Zig types without having to go through an AST first. It's annoying because it uses recursion. Yeah, I would say there's definitely some aspects of this thing that are like suboptimal that could be made better. I think the JSON parsing that's in the library is more advanced in some ways, but it's fine. So turns a Ziggy document string into Zig types without having to go through an AST first. On success, it will populate. Well, okay. If wait a second, let me take a look again at what we do with EOD. We need both. And honestly, here, I think this makes no sense. I think there is no point in us to do this. Yeah, I think this is more correct. Hello, Calder. No, I think we should rephrase this slightly. Since we don't read an AST when serializing the Ziggy document, any error reported by this function should not be immediately shown to the user. Should instead, one, build an AST and report any syntax error. Build an AST and report any error. Actually, this does not apply to overflow. Like overflow, actually overflow in duplicate field you can show immediately. Also known field. I think these guys you can show immediately. Missing field, I would not do missing field instead. But I think these three you can trust at the very least. These two. But you know what? The procedure is still good though. Build an ESC and report any parsing error found. If the ESC does not contain any parsing error, then show the error. Returned by this function. Wait, what? I think we should add a convenience function that does this for the user. I'm thinking that this should be a separate argument at this point. It shouldn't be options. But, eh. Okay, I think, yeah, we should really make a nice function that reports these errors in a cutesy manner. Yeah, I think at this point we should split options and meta. Options should be options and then should be meta. And we cut this stuff out. So how should meta work? Um, Actually, making it a union is a problem because we cannot give it a default value, so we should make it a struct. And then it contains error lock, missing field name, and doc. Although these things are mutually exclusive. Like you have meta doc, you have meta error. This is annoying. So this does meta.doc. I think this is fine. Maybe we can do it like this. Fuck. Ah, there's also options. Fuck. Maybe this guy leaving instead of options wasn't that bad. Oh yeah, accept it as an argument, I guess. There's nothing else we can do. Okay, something along these lines. We can do better though. Okay, I think this is a reasonable error reporting solution. Okay, this seems good. Next, we need to make this compile because we're still using opts out in some places. To be honest, the way that it is structured, we could make it a union. That would make it slightly more type safe. Oh well. Okay, we're back in business. Refactoring successful. We completed this. We should try out, I think, this report errors function and have it report errors in a way that we expect, maybe. So let's add to our test cases a little bit. For example, missing the limiter in Markdown should cause us to get an error. So this should be deserialize leaky. How do you assert the presence of an error in a good way? Something like if the serialize leaky catch and then below assert false. Something like this. SCD try SCD testing dot expect equal error dot. Is there expect error? Yeah. Yeah. Okay. So okay, I get it now. God damn it. So much work. Right failed. Found what? Mm, this guess returns only out of memory. This guy returns. Where is it? Print. This guy returns only right failed. So what is your problem? I'm confused. What is the problem? It's all what? Ooh. Oh, that right. This returns out of memory or right failed, but in here, this cannot be just tried. This needs to be a catch. This sucks. It kind of means that we wouldn't want to accept this stuff as a argument. You know what? It's fine. There we go. What did we see? This print should be removed. And then this is what we got. SD in unexpected token. Okay. So this is good. We also have error reporting. Let's do now duplicate field. Perfect. Now we got duplicate field. Three 12 unexpected token. Found 212 duplicate field, but there's syntax errors. Wait, something is not kicking in as it should. Why is this not doing what it should be doing, which is report errors? Yeah, I'm confused. I'm a little bit confused. Why are we getting here at all? We shouldn't. Oh fuck. I know what the problem is. Is that we're pressing wrong source. That is what we should be passing. Also here. Yep. There we go. The fact that you have to slice first is really kind of annoying. I might want to do something about it somewhere, but not now. 3-1 duplicate field. What is the seed used in your build CMD? No, I was not explained before, but don't worry, Calder. That's it's in the nature of live streams to be repetitive because people join that were not present. People don't are not present for every single thing, so it's normal. That being said, what is seed? There is some to make tests reproducible. There is something that gets randomized. I don't remember exactly what. Like I know some examples of things that they get randomized off of seed, but I don't remember all of them. In any case, it's a way of making certain semi-randomized things reproducible from the CLI. That's it. I don't remember if this hooks into if there's like a test PRNG or something. Maybe there is, maybe there isn't. I don't remember. But there's other randomized things that become reproducible if you set seed in a test executable. It's a test run. It's a testing runtime thingy. No, okay. I think we have enough tests. No, I'm not myself. No, right now I'm not. But it is also used internally. Another example, I believe, is for example, if you want to reproduce a fuzz test, I believe that you might be able to do it that way. In any case, it's a thing that the test runner uses internally, and this resurfaces sometimes to the user. It will more in the future once we have fuzzing enabled. Um, but my recommendation is this: if you have like a test that crashes, you want to rerun the same test, passing in every single argument except listen. You want to copy this thing here. Let's say that this test crashes and you want to debug why. Then you want to do LDB this guy. LDB dash dash this guy with everything except listen. In this case, it didn't do much because my test was exiting with a non-zero exit code, but it was exiting successfully. But you get the idea. Okay. I think we are in a good enough situation. I'm not convinced that this is 100% bug-free, but it is reasonably enough bug-free. And so now we can go in root, and we can take a look at what we have. So the serializer, and we can pass the serialize leaky. Alternatively, we could change this to deserialize, and then we create leaky and arena as functions, and you call deserialize.leaky and deserialize.arena to decide in which you want to deserialize a thing. That's also a way of doing it. It's actually not a bad idea. It's kind of cumbersome as it's named right now. You know what? I'm kind of really tempted to do this. So instead of deserializer, we call it deserialize. And then you call dot leaky. Nah, it's fine. Okay. So we have this. This can go away. This can go away. This can go away. This can go away. This can all go away. We are left with fixing dynamic deserialization. We're stuck with fixing this thing, which I think should be uppercase dynamic. They should change to uppercase dynamic. And then we have schema. Okay. Do-do-do-do-do. You need to ask for a shell that isn't weird. I found myself comfortable with fish. To be fair, I don't use any particularly advanced stuff from it, but it's generally good enough for my needs. And I think I prefer it over Bash. Okay. So our next step. Our next step is to fix dynamic. let's see how this goes, I guess. So here we had dynamic value. Oh, I see what the problem is with dynamic. Dynamic is it's this guy, it's value. Okay, let's do it like this. Okay, I see the problem with this. What's left in Ziggy? Nothing. Dynamic map, blah blah blah, tag. Oh, map is defined outside of dynamic. This should be called dynamic for sure. I think that the map should be defined inside. I think everything should be defined inside of it. Oh, there's tests. God damn it. So there's a KV, array, bytes, integer, float, bool, null. We're missing union. Ziggy options, stringify. So this is serialize. E.Z options.stringify. Serialize. Okay, this can be just write all. Okay. So deserialize. This is not parser error. This is deserializer.error. Now diagnostic. I see why I made that thing thing that had state, because that way we could pass the state conveniently here, and we here could call parse this, parse that other thing without having to re-implement it. I see. Now I see why I made certain decisions that did not seem immediately super rational. Aha. Ah. Is this convenient enough to make me to convince me to go back? I don't know. Um, yeah, I'm not convinced at all. Not convinced at all. So here's how we do it. This parser, um, this parser abstraction is convenient in some ways, but you know what? Maybe not. Deserialize leaky GPA source. What else? T and burst. There you go. To be honest, all of these could be deserialized leaking with just like the payload, basically. I am realizing that there is something sus in here because um hmm. Yeah, how do we deal with top level stuff? Hmm. Even this is easy. Why am I taking? Why did I take this approach? This is trivial. This is return. Why did I do all this work? I don't know. There we go. Okay. We're missing enums and unions. In identifier dot lb and dot rb. There we go. It's a map. We need to do enum and union. Yeah, enum is very easy. Union, not so much. For a union case, unfortunately, we cannot just. Oh fuck! I know why I cannot call deserialize leaky. Because deserialize leaky expects to complete the thing. We actually want deserialize inner. Yeah, we want deserialize inner. Because deserialize inner is the only one that doesn't care about penalizing everything. And then well, but the good news is that we can be given access to it, I guess. Yeah, maybe there is a convenient way of getting this working without going insane. God damn it. I think it should be like this. Deserialize has as the first parameter. Like maybe a start called deserializer that contains a function called continue. Something like this. Something like this. Something like this, I think. And so root deserializer has, I guess, like this. Hmm. This API is annoying to make not too uncomfortable. Yeah, I think that's how it should be. Yeah, I'm doing weird refactorings that I'm not sure will lead to what I hope to get, but who knows? Maybe will. Maybe it's good. This is actually nice. So far, so good. This refactoring seems really good. God damn it. I do it too fast. It doesn't match inside. No, I haven't forgotten. Sorry. I don't know. I'm doing this boring refactoring, so I'm just trying to go through it fast. God damn it. This thing that the match inner doesn't work as it should if you are too fast. It's super annoying. Well, I think we're almost getting there. I don't think that we passed this stuff. Yeah, there we go. Oh, but we have trouble in dynamic. Okay, wait a second. What if we did not have dynamic for a very brief moment? What would you think then at this point? Dot the meta doc. Oh no. We regressed the tests. That's not good. Only 2 of them, but 2 of them have regressed. Uh-oh. 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 So we're doing mostly fine, but 2 have regressed. Duplicate field plus syntax error returns expected error, duplicate field found unexpected. Uh-oh. 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 So let's see how this looks like, roughly speaking, though. Wait, what the fuck is going on here? Oh my god, look at this. What? Why is this guy going up when not selected? That is interesting. What's going on with this font? I think if there's a... It goes up if there's a uppercase character next to it, or like a tall character next to it. What? I don't know. What's going on, man? Oh my god, this is unreadable. Holy shit. I don't know what's going on. How the heck did I regress this stuff? I don't know. Anyway. Anyway. Yeah, do we actually need to pass options around? Yeah, because we observe copy strings in parse bytes. Okay. So how do we regress this use case? I don't that is mind blowing. We're expecting duplicate field, but we found error unexpected. Hmm. Test duplicate field plus syntax error, which is the one above. Yeah, we expect this to end with duplicate field. But it doesn't. How does it end up in 195? Also, what is this weird error trace? 461, 195. Oh, it's because we don't try this. That's why it's confusing. There we go. Okay. There we go. Okay. Regressing this stuff was really weird. Okay, so with this, we are back in business. Let's turn dynamic back on and let's watch it whine about everything. Sure. Go back to dynamic. Let's call it deserializer. I'm starting to think that deserializer should be uppercase. It should be the top level struct. And then leaky and arena, deserialize leaky and deserialize arena should be implemented in the root directory, in the root file. You know what? Let's do this. I don't know. Maybe it shouldn't be defined in here. I don't know. We'll see. But in any case, now we can worry about dynamic. Mm, okay, I think we are doing fine. Mm, okay, so we are we are implementing pretty much struct parsing. Hmm. That is, well, that is certainly something. Okay, so it's a matter of fixing this bad boy. We also have to deal with the unions, though. No, by the way, we did implement all this stuff, I think. So well, no, we did not fully. We're missing dot union case. Here we go. Okay, so we have unions covered. That's good. It wasn't too bad. The serializer abstraction is actually paying for itself really nicely, to be honest. It's really, really nice. Okay, I just need to finish fixing dictionary. This is kind of annoying that we have to deal with field parsing manually. Holy shit. But after I fix this, I think we're gonna be fine. So I think I'm gonna call it a day. Oh my god, I've been streaming for almost 8 hours, so this has been a productive day. So, yeah, this was intense, but we almost powered through. Instead of an collapse, we'll see. But we powered through 90% of the things that remain to do when it comes to updating all this stuff here. So that's good. And it doesn't seem to be riddled with bugs. I also got a chance of fixing a few subtle things that were annoying, and yeah, that is actually nice. That is actually nice indeed. So I think I'm gonna stop here. I'm gonna take a break, recover some energy, and then either later today or tomorrow, finish dictionary. And at that point, we will have recovered pretty much everything. There, we will have reached feature parity. Uh, minus this logic bug in schema validation. This is exciting. I actually expected this to be a much longer adventure, but this was actually pretty straightforward. I have definitely learned a lot of things about writing languages. That is for sure. Okay, thank you for hanging out, and let me see if there is anybody doing Zig. There's Iron Beetle and Ethernet cable. You know what? I'll send you all to Iron Beetle. Let's go watch some Tiger Beetle content. Actually, is it Iron Beetle? Well, it doesn't matter, but yeah, it is Iron Beetle. Okay. So say hi to my flat for me. And see you next time.